ammonia, NH3, is a weak base. So we can write the reaction of ammonia in water very similar to the way we reacted the acids. This is weak, so we know we're going to get forward reaction and reverse reaction. This is called an equilibrium symbol, which tells you the reaction is not complete. It will react less than 100%. Ammonia being a base, that must be where the arrow is pointing. So the arrow won't start from the ammonia. The arrow always starts from the acid, and it points towards the base. So remember, this arrow represents a transfer of an H+. If we add one extra H to NH3, we'll have NH4. The original charge was neutral, and it accepted a positive hydrogen, a proton, so it'll have a positive 1 charge. The original water lost an H+, so it's going to have one fewer hydrogen, and it will have a net charge of -1, so that makes the hydroxide anion. It's still neutral on the reactant side, and the product side is neutral. Mass is conserved. We have the same number of elements on both sides, and we have the same charge. So if you notice in these examples, with the acid, water acted as a base. But when we put a base in the water, water acted as an acid. So this is important to note that water can either be an acid or a base. And the technical term for that is amphoteric, a substance that can act sometimes as an acid and other times as a base. When we wrote out these reactions, for example, with this ammonia reaction, notice that we have chemicals that are very similar to each other. NH3 turns into NH4+. The only difference between NH3 and NH4+ is one H+. In this case, the product side chemical has one more H+ than the reactant side. And if you look at the water turns into OH-, hydroxide. The only difference between these two is this time the one on the left has one more H+. These make up what's called a conjugate pair. A conjugate pair, two chemicals that only differ by one H+. So in this example, ammonia NH3 and NH4+, the ammonium cation, are a conjugate pair. Notice one is a base on the reactant side. Its conjugate is an acid on the product side. That's always going to be the case. H2O and OH- make up a conjugate pair. One of them is the acid, one of them is the base. The one with the extra H+ is always going to be the one that's the acid. NH4 plus OH-. NH4 is an acid. We could draw the arrow here to show how the reverse reaction takes place. NH4 donates a proton to OH-, that turns the OH- into H2O, and NH4 turns back into NH3. We could also have the arrow, just like we had, from the acid to the base on this side. So always notice that a conjugate pair is made up of one acid and one base.